And I put anemias because there isn't just one anemia. Anemia isn't just a simple iron deficiency. There are different kinds. There is the obvious kind, which is nutritional deficiency, which is obvious. Those that do nutrition will cover this to a certain degree with Justin, but the idea that if you have deficiency of iron in the diet, you will have a decrease of iron in circulation. Why does a decrease of iron in the circulation affect oxygen carrying capacity? Right, and you need iron to cause the structural integrity of the hemoglobin molecule. If you haven't got the iron, then what you've got is a molecule that isn't structurally sound. So it's much harder for the hemoglobin to be moved efficiently around the body.
Now, I think like an iron deficiency, like
yeah, absolutely, because they've got less capability of moving the oxygen. So particularly when they stand up, and they get that sudden change in blood pressure, because they haven't got the capability to move their oxygen, they're more likely to faint from it. So normally, if we get a hemoglobin deficiency, it's normally accompanied by a red blood cell count reduction. Not always, but normally. And one would argue, as I've put here, according to Bassett and Howley, it conforms to the supply and demand model. In other words, if you're supplying insufficient oxygen to meet demand, we've got an imbalance, we've got a problem. So anemia is of real concern to us when working with endurance athletes, working with any athlete, but particularly endurance athletes. So, three major causes. You can get a loss of blood, you can get a decreased rate of red blood cell production, or an increased rate of red blood cell destruction. And one of the big causes of an increased rate of red blood cell destruction, interestingly, is an anemia called pernicious anemia. And pernicious anemia is actually very common. Pernicious anemia is caused by a lack of vitamin B12. If you have a lack of vitamin B12, you have an inability to produce what's called intrinsic factor. So pernicious anemia is caused by a lack of vitamin B12. If you have a lack of vitamin B12, you can't form intrinsic factor. What's intrinsic factor? Intrinsic factor, you've got to think of it a bit like the scaffolding that holds the red blood cell molecule together. So it gives it the structural integrity. If you haven't got the intrinsic factor, you've got red blood cells that look like a red blood cell, but actually now aren't strong enough to cope with the pressures that are caused by the changing in the peripheral resistance. They break up. And that's actually an incredibly common form of anemia, particularly in the older population group. We get the nutritional deficiency as well. That's a very obvious one, just that we've got a lack of iron in the blood, or we have an inability to retain iron. And one of the big things I would say about using iron supplementation is you've got to be incredibly careful with it. A lot of people will supplement with iron either because they're anemic or because they think that they need to supplement with iron because they need to increase oxygen carrying capacity. If you supplement with iron, too much iron is poison. And the iron actually poisons the liver. So if you just go on a regime of just taking iron supplementation because you want to increase red blood cell count, but you were not anemic, actually all you're doing is poisoning the liver. So you do 2 weeks on, 2 weeks off, if you're going to do that. The simple truth is, though, it doesn't work. Okay, it only works if people are anemic. Once you're at a normal level, you're not going to retain it. In fact, that becomes quite an expensive peak. Okay, and anybody's ever taken desiccated liver, because everybody says, oh, liver really rich in iron, I'll take lots of desiccated liver. Again, if you're at the natural equilibrium, you're not going to retain the iron. It's not going to suddenly trigger an increase in red blood cell production. You take it back out. Okay, so the manufacturers like Tropicana are laughing at you. And rubbing their hands with your colleague, going, oh yeah. The other extreme is the polycythemias. So the polycythemias don't tend to see this particularly in athletes, but you excessive production of red blood cells. And that's more of a medical-based condition than it is perhaps what we call an exercise-based condition. But of course, it's not just that you increase red blood cell production, you increase production of neutrophils, platelets, and so on. The result is, what happens to blood viscosity? Does blood become thicker or thinner with polycythemia? Thicker. Because the thing that we're not changing now is plasma volume. So polycythemia is actually quite a significant medical condition. Again, I'm not going to dwell on this particularly, but this gives us an idea of the effect of the anemia on the process of erythropoiesis. It also gives you, note, some values for our red blood cell count that we were talking about earlier on, but also some important data in relation to ferritin. So ferritin, iron, gives you the normal values for iron concentrations. Yeah. I'm going to show you this one though. This is quite important. This is kind of a checklist. So if you're going to test an athlete, and you look at the scores, and you've got a score greater than 70 micrograms per litre, you'd have normal hemoglobin scores. So yeah, normal. Then what do you recommend? You wouldn't even recommend iron supplementation, just a standard annual check. If it's the top though, where you've got a very low score, less than 20 micrograms per litre, then we have to look at iron supplementation because they're low. So they will absorb the iron. It will help to increase the red blood cell count. We're going to recommend some form of testing. You'd certainly look at haematology, the hemoglobin score. You would certainly do some kind of performance test. And then we look for these positive and negative responses. Are they absorbing the iron? Some people don't absorb the iron, which then poses another problem for us. That's a really important checklist for us to follow.